During the Pleistocene, a unique species inhabited this corner of the Mediterranean and managed to adapt to the island environment, transforming its anatomy and way of life. What were the features of this extinct mammal? For thousands of years, the island of Crete was home to a unique creature, the Hippopotamus creutzburgi, a dwarf hippopotamus that managed to adapt to the characteristics of this island environment. The fossil remains of this species, discovered mainly in the plateau of Katharo, represented a challenge for paleontology due to their fragmented and deformed state. However, today technological advances revealed, for the first time, what this mysterious mammal looked like, thanks to a complete digital reconstruction of its skull. Nikolaos Geroukakis, from the Department of Geology and Geoenvironment at the National and Kapodistrian University of Athens, and Demetrius Makris, from the Department of Conservation of Antiquities and Works of Art at the University of West Attica, led this project. Both researchers, based in Greece, mark a milestone by digitally recovering the original shape of the H. creutzburgi skull. The digital model not only allows us to appreciate the shape of the skull, but also to better understand the morphology and evolutionary adaptations of the Cretan hippopotamus. The researchers reconstructed the missing parts using anatomical data from related species. This scientific breakthrough opens the door to new research and museum exhibitions, as it helps to rediscover the island's prehistoric fauna and understand the evolutionary processes that shaped this species. The results, published in digital applications in archaeology and cultural heritage, stand out both for the use of advanced digital tools and for the possibilities for future research. From fragment to complete skull, the digital reconstruction process. The skull of Hippopotamus creutzburgi was extremely fragmented and deformed, making any attempt at physical reconstruction difficult. According to the researchers, the fossils, found in the Katharo Plateau during excavations between 1998 and 2002, included 3 partial skulls and an almost complete jaw. According to the study, the specimens were incomplete and dorsoventrally deformed due to taphonomic deformation, which made it necessary to look for digital alternatives for their study. That is why, to begin with, they carried out a 3-dimensional digitization of the fossils using photogrammetry, the most reliable and economical method that produces results with high resolution and precision. With this, they obtained detailed 3-dimensional models that will preserve the integrity of the original remains as they progressed in the reconstruction. In the next stage, the team used Blender, a software specialized in computer graphics, to reposition and assemble the fossil fragments. For the dorsoventrally deformed skull, we used a virtual approach that would have been destructive if applied to the real specimen, the authors explain in their paper. This process was complemented with tools such as digital reinforcements, designed to correct the anatomical deformations present in the remains. One of the notable innovations was the design of a digital exoskeleton in Blender, which incorporated 23 virtual armatures to address the most extreme deformations, particularly in the jaw. This system allowed the fragments to be repositioned and aligned according to reference anatomical parameters. The researchers in the paper said that the complexity of the specimen forced the development of new techniques within the software, which sets a precedent for future similar work. Finally, to fill in the missing sections, they turned to anatomical references from modern hippos and related species. This made it possible to create a complete model that, according to the study, represents almost the entire skull of H. creutzburgi by combining and retroforming the available partial skulls, offering an unprecedented view of its anatomy. A window into the past, the morphology and adaptation of Hippopotamus creutzburgi. The digital model of the reconstructed skull allowed the researchers to explore in greater detail the morphological characteristics of Hippopotamus creutzburgi, being that this species stands out for its uniqueness in the evolutionary context. According to the study, the reconstructed skull exhibits similarities to modern African hippos, Hippopotamus antiquus, and dwarf hippos from Madagascar, although it exhibits specific adaptations to Crete's island environment. The small size of H. creutzburgi illustrates the phenomenon known as the island rule, in which large species tend to decrease in size when they inhabit islands with limited resources. This hippopotamus, which would have reached dimensions similar to those of a juvenile Hippopotamus amphibius, adapted to the conditions of Crete and developed a morphology that favored its movement in rocky terrain. A key aspect of these adaptations was the shape of its limbs, which differentiated it from its continental relatives. The researchers noted that members of H. creutzburgi were adapted to the rocky environment of Katharo, allowing it to walk in a more digitigrade manner, giving it a more goat-like appearance than a traditional hippopotamus. This feature reflected a functional adjustment to the mountainous terrain of the island, where conditions contrasted with the river habitats of present-day hippos. The reconstructed skull also allowed for the comparison of dental and bone aspects with other species of the genus Hippopotamus. The teeth of H. creutzburgi showed were compatible with a diet adapted to the resources available in Crete, which reinforces its ability to adapt. The analysis of dental wear facets and bone structure indicates feeding habits specific to the island ecosystem, the researchers explained, noting how this dwarf hippopotamus developed strategies to survive in an environment of scarce resources. In addition, the researchers highlighted that cranial proportions suggest unique features in terms of shape and size. The skull exhibits significant differences compared to its continental ancestors, especially in the proportions of nasal and orbital structures, which could indicate variations in sensory perception or interaction with its environment.